Okay, class, we're back. I hope that you done your assignment. Now, a very quick announcement. We do have a few weeks coming in for the end of the semester. I will be sending you an email, an announcement on the e-learning, telling you the steps when it's going to be your second assignment and your test two. The one thing I would like to suggest that the fact that the next chapter, and the next chapter is we'll talk about the preparing data, and just a second. Okay, preparing data and for quantitative analysis. Now, basically, what we are the objective of this chapter is will be mostly we need to describe the process of data preparation, how we do prepare the data. So when you do your assignment, it's the same thing. You need to look how they did prepare their data, if there is any information about it. So, or when you're preparing your data from the secondary data, you need to understand why did you pick this over that one, and do the analysis. Then we will talk about discussing the validations, editing, and coding of surveys, explaining the data entries, procedures, and how to detect errors. And we will describe the data tabulation and the analysis approach for it. Now, basically, value of preparing data for analysis, data preparation process, converting data from a source into a usable code for data analysis. What it means is like we do have all these information, and we're all these data, and we have to get convert all these things into final thing, which is information, useful information. So there is a process of doing that, and to do that is we collect all these data, and we putting it in a usable code in order to analyze it, and then we come up with proving the hypothesis, and then proving or disapproving the hypothesis is one of the two, and then to the building the theory. So it is assessing and controlling the data integrity, ensuring the data quality by detecting the potential response and non-response bias, whether there is a potential bias when they're responding or not responding, whether by the interviewer or the respondent, dealing with the inconsistency there. If there is something is not, according to all the data is inconsistent, then we need to deal with it. Converting data to multiple format to a single format. If there is data that's been collected through the phone or through the mail, or we need to convert it all to a single format. So in general, if we look at the top, there is, when we do an error detection, we're doing the data analysis, we look at the validations. We look at the editing and coding, whether it's been edited correctly, being coded correctly. We look at the data entry, whether it's been done correctly or not, incomplete or complete, and tabulations of it, and data analysis. Now, determining that whether a survey, interview, or observation were conducted correctly and free of fraud or bias, is that what you call a validation. One of the things is that some researchers they're getting probably a little bit lazy, or they don't, or they start, making up the information. So that's what you call cheating or falsification in data collection process. So they do, for example, they talk to their family and friends to enter the data, or they enter it themselves. That's what is collapse toning is all about. Now, so the area covered by validation is that we need to check for a fraud. We need to screen the data that we have. We need to see whether it's done the procedures right, and there is a completeness in data has been entered, completed, or incomplete. And when you do a survey, many times that you will find out there is, halfway is done and incomplete. And this is one of the hazards things of doing, the surveys. Now, when you do an editing, you do the raw data in checked for mistakes, error into either by the interviewer or response. So you will find, like, when, for example, there was a question that a person is answering, or the interviewer answer was totally not answering the same question, probably. Sometimes you do questionnaires where some part of the question will give you a feedback of the another, just you change the locations of the answers, and you will find out whether there is an error entering. By reviewing a complete interviews from the primary research, the research can check the several areas. This is what you call an editing, asking a proper question and recording answers accurately. If they are not being answered the proper questions, not done, or answering inaccurately, you have the data being collected, a bias or something that's wrong or useless. Correcting the screen of respond and complete the accurate recording open-end questions, especially in the open-end questions where you need to really review the answers. Is it done? Did the interviewer ask the right question, or did the respond was right to the right questions? So these are the editing that you need to do. Then when you start, putting all these collected the data, and you felt that there is the data has been corrected and reached to the first stage, you start grouping these answers, and this group of the answers, you start putting a numerical to them. And the numerical is just like kind of called a code, which is a reference, and you need to make sure these codes are set up, and the numerical set up earlier before you start entering them. So a well-planned constructed questionnaires reduce the time spent on really the coding. If you write a good questionnaires, there will be most likely a good answers and a clear-cut answers where you can easily put a code on it, and the code is a numerical. Now keep in mind, this doesn't mean you're going to use these numerical directly. They might be referencing to something else, which is, that's what you called a code. Now, four-step process to develop a code for a response. You generate a list of many potential response. We said that in early stage, before even you go for your surveys, you need to set up the coding for it. And this code is, it's a general list of many potential response. So you can imagine what's the answers, and then you put a code if he answers this way, that this is the code uh, attached to it. If he answered this way, so it makes it clear. Then you consolidate the response. Uh, you know, question 5, you put them all together, and then you question 4 all together, question 6 all together, and then you look at their coding, and then you start assigning a numerical value, which is as a code, and that all these response converted to a code. Now you work with the code as assigning a code value to each response. Now, when you start entering these codes, there might be some data entry errors involved in it. So hopefully, if you have an application or you use a kind of an Excel sheet, you want to make sure that these, if it's numerical, the cell would only accept the numerical part of it. So you need to want to make sure that the whole, there is no error involve error detection, if there is a missing data, or you need to make sure that the data is organized properly, because you probably have 10 questions. So all the the question number 5, they have, you separate them all, and you already put a code on them, and these codes would be kind of together in to see, to calculate the means or the values or the mode of it. So when you identify an error from data entry or other source, what you need to do is determine if the software used will perform the error edit routines. So if there is a numerical and you put something, or you above the numbers, it will show that it's not acceptable. Start, review a print representation of the entered data. You can look at it manually, and then you run a tabulation of the survey and find out, the highest range and the lowest, or highest number and lowest number, and between them, and find out which, the range, the mode, and the mean, and all these process of doing the statistical calculation, which is we saw it in the video, on the first video. And so once you find a missing data, there is a 2 counter approach for it. First is to replace the missing data or missing value with a value for a similar response. So you probably, when you see two respond are very similar, and on the question 5 is missing, so you need just to put the same value that's in the previous sheet. That's one of the way of doing it. The second is that the question, you need to probably put the mean of it, so that probably another way of correcting missing data, and entering a missing data. But we want to make sure that you don't put so many of them, because that might affect the result of it. So these are 2 ways of doing it. Is one, you look at the similar response and you try to enter the data on the one missing to it, or the second one, you just use the mean of that it's using. So use, as it says, use a mean of a sample for responding the similar characteristics. Now, if it's 1 or 2, and it's out of 1,000 that you can, overlook at it, but preferably not to overlook at it, and you just enter the similar response, or you need to enter the mean of it. Use the mean for entire sample that answer the question as a replacement value, which is, as I said, is now recommended to do so. Now, the data tabulation, it's classified in one-way tabulation, which is categorizations of a single variable. When you have a one variable and you start categorizing and start finding a mean, mode, and median, It's a one variable. But cross tabulation is maybe you have more than one variable that, and you need to your constructs derives from a different variable. So this is where you do a cross tabulations for it. Now, the one-way tabulation determines the amount of non-response to individual question. Locate the mistake in data. So when you look at it, it's easy to find out where is the mistakes in data and communicate the result with the research. This is because it's a one-way tabulation. By constructing one-way, it's a frequency table. And this is a sample of how a tabulation comes in, and usually it's like, the frequencies, whether the valid placement, and we will be talking about these things this is in the restaurant case, but we will be talking about more about the frequency distributions of the data that you've been collecting. In the reviewing the output, look for usually indicating indication of missing data. You need to look at where the data is missing, how you're going to treat this missing data, and determining the valid percentage, as we said, and you need to do the summary statistics for that. This is very similar like the previous example, but this is where you look at the missing data, then start entering, treating that data to purify it through entering similar respond or the mean of it. So basically, when you talk about the descriptive statistics is used to summarize and describe the data obtained from a sample response. So here, where you start looking at these numbers and start converting it to something that something called central tendencies. And in this next chapter, we will talk more about what's the central tendencies and dispersion. It's basically start, making sense of the data collected and approve or disprove the null hypothesis, which we spoke about it on chapter 2 about it. Now, once you put these data together, you start, in a way, try to show it in a pie chart and, regular charts. And it's much easier for the reader, for somebody who looks at it, to understand it from the graphical point, because numbers would not help, especially if there's lots of numbers, would not help a customer will understand it. So the power for communication, key research results generated from the primary data analysis, and these are supposed to be, put in a kind of a chart, understanding chart. So when you do your presentation, you need to show me some chart driven from these data that you've been collecting. So what I'm going to show you on the next so the whole situation is when we do a basic data analysis and quantitative research. We're supposed to do this primary research as a final assignment, but because you are not able to go and collect this primary data, and you're going to get secondary data, you need to validate these information and convert them to something that the management understands. So in order for you to convert them to something that management understand, you need to know the technical part of it, and then you do the the translation of these technical parts. So in chapter 11, what we will be talking about, just give me a second. Um, uh, we will, or we will explain the measure of central tendencies and dispersions, as we promised. Describe how the test hypothesis using the univariate and bivariate statistics, apply and interpret analysis of variance, and utilize the perceptual mapping to the present. Now, if we are going to miss something, hopefully next class I will be going more deeper on this and explain more what does these terminologies mean. Now, value of statistic analysis is helps researcher understand the response, the summary statistic used to identify important information. Now, you need to do this, present in a large, when the data is presented in a large amount and you start entering it to your Excel sheet or your certain application, and then you start driving the mean and mode and median of it and start analyzing this information, then you need to convert it to, something understandable for the management they don't have the statistical background of this products. And this is what we call the basic statistic, and then goes to the descriptive analysis. Now, as we said, mean is arithmetic average of a sample. So you collect everything and you divide by the numbers. This is the average. So the average people who lives in Canada is at 25 years old or 35 years old. The average height in Canada is a 5'10". So, but I'm pretty sure in Middle East, for example, the average height is 5'5". And so here considered to be 5'10". So 5'10" is an average, is not the tall one and not the short. So it is the mean. Collect all this and divide by the number. And then you have the median, which is the middle value of a ranked order distribution. So the middle value is a different than the average, because in the middle value, it's what's you go, it's numerical thing. You add each numerical separately, and then you get the middle one. In the mean, you add them all together and divide by the number. And the mode is what is the most repeated one, most common value to set of the response of the question. So these are the three terminologies that you will be probably trying to understand. This is how it looks like when you're doing it on an Excel sheet or a certain solution that they do that. Now, then you have something called range, which is the video indicated it also. It's about, the distance between the smallest and the largest value in the set of response. So you need to know, for example, people who make $100,000, how old are they? As a youngest one and the oldest one. And so you probably then you'll find out whether the people who's making $100,000, who they are targeting your market, for example, if you're selling a high-end product, something like that, because you need to find the range of people within your target market. Then you have the standard deviation, which is the average distance of distribution from the value mean. So you have the mean, and you find out what's the mean, but then you find the next person is say he is the mean is, like, say 5'10", but the next person is 4 feet. So the biggest difference there. And if you're looking at, you say the mean is an average, but then 4 feet, and then you find another person, it's 7 feet. So it's the standard deviation is pretty high. And probably you have one person in the middle who gives the impression that the average people are that height, which is, but there are not many of them. But with the standard deviation, it shows you this average, how condensed in the middle. Then you have the variance, which is the average squared deviation about the means of distribution and the values. And we said the only reason we do a squared because we cannot have a minus 5 feet tall. We should have a 5 feet tall person. We cannot have a minus of $100,000. It doesn't, distance, especially in a distance that you cannot have. So these are why you use a square to take away the minus part of it. Now, how to develop, once we get all these information, the variance, the mean, the mode, all these information, we start to do the hypothesis, which is we start to test our hypothesis and see whether our hypothesis is true or not. So the hypothesis basically will tell us, for example, most of the people, we said the average people is at 5'10", and then we would notice that the mean, which is the average, 5'10", but the standard deviation is way, the variance is pretty high. It shows that it's not in the, most of the people 5'10", so that the hypothesis does not represent itself. So what we do, we review this research objective and the background information. Then we develop a null and alternative hypothesis. A null and alternative hypothesis is just, we say, this is the reality in the situation A. Null hypothesis, we need to prove whether it's not the reality in situation A. So this is what you call a null hypothesis, and how we derive it from the evidence that we get. It's like in a court. In a court, everybody is innocent until proved it's guilty. Null hypothesis is the way to prove this person is guilty. So the hypothesis is the person is innocent. So you come up with the evidence, which is mean, average, mean, mode, values, and to show that he is guilty. So that's what it means in a null in a nutshell, like a sample to bring it. Then you start, because your hypothesis will drive your theory to build your business plan according to that theory that you're going to come up with it. Then you start to really determine the sample distribution and select the appropriate sample test. So we said in the early classes that you need to have a hypothesis, and the hypothesis would build a theory, but you need to approve that hypothesis, and then you move back around to the hypothesis. Okay. Okay. Once again, I'm not going to change the way I work because I'm not going to confuse everybody. Once I open your email, I'll send you a notification that I received it. Determine the sampling distribution and select the appropriate sampling test. So, you know, you have the hypothesis and you start doing, you know, as we said, your sampling test and through the survey that you're going to do. Then determine the level of statistics significant and determine if the difference are statistically significant. That makes, you know, prove this person is guilty or not, as I said, in a court. And then you utilize these numbers, these mean and moods, and you know, variance, all to prove this the null hypothesis. So then, if to do that, so let's say person is innocent until proved is guilty, then you start doing a null hypothesis saying this person is guilty, and then you do the surveys and research and find the mood and mean and medians, and then you start, you know, find out that the mood and median prove that this person through the evidence is guilty or not. So this is when you accept or reject the null hypothesis. And if you prove it, then you will do, you know, after the hypothesis, if you prove the hypothesis, then you build your theory, and then you start doing the marketing plan and business plan and all according to that. So let's assume you have a product that you have in India that you want to bring it to Canada, and it's geared toward people 18 to 22 years old. You want to, for example, the hypothesis, your hypothesis, most of the 18 to 22 years old, they live in Scarborough. So I'm gonna target the Scarborough. And your theory is you need to build whether this product, you know, most of the people who lives in Scarborough are 22 to say 18 to 22. So you do your research, you do your surveys, you do your, and you drive the sampling, and then you find out the mean, the mood, you know, the variance there. And then if it's really most of the people lives in Scarborough is between 18 to 20, so you proved your hypothesis, which is drives your theory. This is the product is targeting 18 to 22 years old. This is how it's done accordingly. Now, you need to do some analysis, as we said, the relationship. We spoke about it and you do the sample statistics, as we said, and you do the factor influencing of the choice approach. So, you know, number of variables, scale of measures, all these parametric users and non-parametric statistics. Now, in the parametric statistics, that is very clear when you have a unit, say 18, 19, 22 years old. But in non-parametric statistics, was just not clear with the unit, happy people, not happy people, all these things. It's a different construct that you're going to build for it. So these are the data that you're going to do processing. Now, for doing a hypothesis is basically univariate statistical test used to test the hypothesis is with a proposition about the sample characteristic of giving a standard. So the test one variable at the time. So you do one variable at the time to see whether, okay, the question, for example, if in the Scarborough, majority of people is between 18 to 22, and they are female. So you do first majority if there is a female, and then you do whether the people are 18 or 20. These are two different variables, and you need to do the null hypothesis, test each variable separately. And then they put them together, and they will put to these things in accordingly. So there is a three type of you do is the test your hypothesis is you're doing the chi-square, the test square, and the analysis of variance. And we'll be talking about more about this in the next class, but it's not bad to introduce it in general about it. And the test of the hypothesis that compare the characteristics of two variables. Once you do two variables and you're looking at the two variables, not single variable, two variable, and you look at the something called chi-square, test square, and analysis of variance. When you do one variable, mostly you're going to look at the mean, mode, and median. So then the chi-square, the first thing is that you basically what you do is you look at the observed case and minus expected case, multiply by 2, and just to take the negative part of it out, and what's the expected. And this is mostly used to do in the observation and assess how closely the observed frequencies fit into pattern of the expected thing. So you probably, stand there in the middle of Scarborough and start looking at whether it's really, you observe people, say 100 people, and you tick in that 50 of them were, or 70 of them were between 22 to 18, and they're female. And but you observed those 100, and the expected supposed to be 60%. So 100 out of the 70 divide by 70. That's what the chi-square. You can do the calculation for it, but it's usually is done for more than one variable, and this is where you do a comparison of means. And if you have two or more group of respond to that test that are tested, or through they may come from a different population. So when you do a comparison for the means, you have two type of comparisons for the mean. You have independent samples, which is, the independent samples comes from two different group, and they're not connected to each other. And then you have the related samples, which comes from one group, only one, a group of it. And you want to look at the two different group, because you want to make sure whether you have done all the research correctly. And if you want to look at the inside one group, you want to make sure that you understand your data has been entered properly, and it is all done within the group itself is done properly. So you do the test to compare the two means, and this is how it's done. Utilize the t-distributions. And I will share you this data, this information, and it's usually done for less than 30 people. When you do the sample analysis for 30 people, it's called the t-test. So you are testing your mean, mean, whether it's been, done properly or not. And you might, if you have to do a primary data, which is in your case is not in today, you need to look at this in a detailed base. Now, analysis of variance. Determine whether a variance, 3 or more means are statistical different from one another. So the F test, which is the statistical evaluation of the differences between a group of team. Now, just to want to understand, mostly we will talk about it on mostly on the next class, which is the variance between groups and variance within the group. So you have, which is called F-test, which is you do the ANOVA of the variance within between two different groups. It according to the same group itself. These are ways of evaluating how these variances, whether it's fine or not in a proper terminology is done. Now, here's where I want you to look at a very short, probably we're gonna run to a limited time, map to illustrate application in a marketing research. Now, it's always done about the new product or the new market, and it images the measurement. So you need a graphical, and you need to advertise and do the distribution for it. So the best way of looking at it is the fact that, let's say, once you do the calculation, once you do the studies and surveys, and you make the primary data as research, or you can collect it from the secondary data as this one is showing in this, you probably gonna do say two variables there, and the two variables you want to see whether their food is hot or not, and then you go to all these fast food restaurants and check their how hot, how fresh is their food, how hot is their food, and in the same time you wanted to see whether they are fresh. This is a different variable, and you also go to check on these the variables of it. So these are the two two variables that you are checking on it, and then you put it on the scale from say 1 to 5. So 1 to 5 and 1 to 5, and then you see food very hot is giving you a scale of 5, and food of you put it very not too hot, scale of 1, and the freshness is the same thing. And then accordingly, for example, McDonald's and Burger King, as a fresh food, you're probably gonna give it 2, and then as a hot food is you're giving them a number 4. This is how it makes it clear for the management to see, for example, where do they fit, or where the competition fit, and where they want to be. So if they want to promote the freshness and more or less, let's give it an example. A McDonald's and Burger King, they are very low in a freshness. So now they are pretty clear. They are, an average in a hot and freshness. So they can improve their operation and move it to a freshness, or they can do the both and make it more hot food and more freshness, which is they will reach here if customers seeking a freshness food and hot food. Now, so I just wanted to show you something before we take it's a step of making a decision, and it's
decision making. First, you must formulate a hypothesis. Second, once you have formulated a hypothesis, you will have to find the right test for your hypothesis. Third, you execute the test. And fourth, you make a decision based on the result. Let's start from the beginning. What is a hypothesis? Though there are many ways to define it, the most intuitive I've seen is: a hypothesis is an idea that can be tested. This is not the formal definition, but it explains the point very well. So, if I tell you that apples in New York are expensive, this is an idea or a statement, but is not testable until I have something to compare it with. For instance, if I define expensive as any price higher than $1.75 per pound, then it immediately becomes a hypothesis. Alright, what's something that cannot be tested with a hypothesis? An example may be, would the USA do better or worse under a Clinton administration compared to a Trump administration? Statistically speaking, this is an idea, but there is no